Okay, so for this next one, there's a coefficient already out there. Do you see that 5? Don't lose that. But we're going to take the cube root of 54x to the 5th y9, and there's already a 5 out here that we're going to multiply things by. 9 times 6, right? 9 is 3 times 3. 6 is 3 times 2. How big should our groups be this time, class? You're going to say 3, right? Okay, because the index is 3. So there's a group of 3 3's. Cube root of 27 is a 3. So that 3, that's the cube root of these 3, this group, that gets multiplied times the 15. Times the 5 to make 15. Okay, I got ahead of myself. 15 out here, leave some room for the x's and y's. Cube root, don't forget the index. And then what's left over? This little extra 2 so far. Okay, good. X to the 5. I have 5 x's. How many groups of 3 can I make with 5 x's? One group of 3. One group of 3 x's. And that'll take care of 3 of these 5 x's. How many group x's are left over if I took away one group of 3 x's? Well, there's 2. So x squared inside y9. How many groups of 3 y's can I make? 3. 3 groups of y. If I have 9 y's, y cubed out here. Anything left over? Nope, because I used all those 9 y's to make the 3 groups of y's that I needed, right? Okay, are you trying to get this? All right, now look at this here. Don't let this freak you out. It looks hard, like divide, but here's the cool thing. We can write this all under one big radical, make a fraction, okay? And then you can actually reduce the fraction here using which rule, class? Which rule do we use with the x's? If you said quotient rule, you're right. Okay, so 50 divided by 2, first of all, is 25, isn't it? 25. And then quotient rule here, subtract exponents, x squared, right? And square root, this is a perfect square, 5x. When it's a perfect square, there's no extra radical stuff, right? Okay, cool. Next. All right, this looks awful also, but let's see if this trick will work. Cube root, we're going to make one fraction. We're going to use our quotient rule that we know so well, right? Going to divide the coefficients and reduce them. Okay, so 2,000 divided by 2 is 1,000. 1,000. Okay, 1,000. All right. Okay, quotient rule here. X 13. 13x is up here, 9 there. Subtract exponents, right? X to the 4. And then here we have what? 9 y's here and 2 there. Divide those. Quotient rule means subtract exponents. Y to the 7. Okay, so now cube root of 1,000, 10 times, that's a perfect cube, that's 10 cubed, so cube root of 1,000 is 10. X, cube root of x to the 4th, how many groups of 3 x's can we make out of 4 x's? Only one group, right? One group of 3 is going to leave us a leftover x. So 3 x's came out here as this, right? This is the representative, and then the next x to make 4 is in here. Okay, cube root of y to the 7th, how many groups of 3 y's can we make? If you said 2, you're right? So y squared, right? Y squared, that's a 2. Okay, that's a bad 2, but it's a 2. Okay, that takes care of 6 y's, right? 2 groups of 3 y's each is 6 y's. And what do I have left over? I have a single y when that goes there.